Hi guys, welcome to the last video of the year. This is 10.1.4, how can I find the angle between two vectors? The angle between two vectors is called the dot product, and we have been working with a number of operations with the application type problems, so we're going to see how we can use the dot product to solve some of our application problems. Before we jump into the dot product, we're going to review an application problem. Let's take a look at our warm-up. It says a boat is headed upriver at an angle of 50 degrees with a rate of 20 feet per second. The current is headed upstream at a rate of 13 feet per second, and the river is 300 feet wide. Part A says to give the resultant vector of the boat and the current of the river together. But first we're going to draw the diagram. Okay, so it says that our boat is headed upriver with an angle of 50 degrees. And this is just the angle measure. It's not, so this is our standard position angle measure. It's not a heading angle. So this is 50 degrees. And then let me grab my blue. It says that the current is, now this is on a heading, headed upstream. So upstream is due north. So this is my current vector. Okay, that's the current, and let's put this as the boat. Okay, so we need to find the boat vector. And remember, we're going to do the magnitude times the cosine of the angle. So the magnitude is 20 feet per second. So it's 20 cosine 50 for my x component. My y component is going to be 20 sine 50. And we're going to use our calculator in degree mode to calculate that. And we get 12.856 and 15.321. Okay, and then we need to find the current vector. So again, we're going to do magnitude times the cosine for the x component, and then the magnitude times the sine for the y component. Now, it's on a heading of, it says upstream. Well, what angle measure would that be? That's going to be 90 degrees. So it's 13 cosine of 90 and 13 sine 90. Okay. Recalling that cosine of 90 is 0, my x component will be 0. Whoops. The y component is going to be 13 times 1, because the sine of 90 degrees is 1, and so that's just going to be 13. Okay, so we need to find our resultant vector. Okay, so it means that we need to add together our x components. Let's do the one that I already have calculated. So it's going to be 12.856 plus 0. And then we're going to do our y component, 15.321 plus 13. So 15.321 plus 13. Okay, and so we get 12.856 and 28.321. So we have a resultant vector, and let's move on to part B. It says, how long will it take to cross the river? So we need to recall a formula that we used a little bit ago, and by a little bit I mean month and a half. So, but you used it in Algebra 1 and Algebra 2. Probably physics and some of your other science classes as well. Distance equals rate times time. Okay, and so let's look at what we're given. We know the distance is 300 feet. We're looking for time, and we know the horizontal component, I meant to have a highlighter, horizontal component is 12.856. Well, what is that? That's the rate that we're going to use in on our equation. Okay, so let's fill in everything we know. Distance equals rate times time. So we have 300 is equal to 12.856 times time. And so let's just divide, and we end up with the time, dividing both sides by 12.856. Okay, let's write our answer over here. So crunching it out, we end up with 23.335 seconds. So it takes approximately 23 seconds to get across the river. Okay. Part C asks, how far up the river will the boat arrive? Okay, and so now what we're working with is our vertical component. So 28.321 is our vertical component. We are still working with the same distance equals rate times time equation. So let's start with that. Distance, not with a highlighter though. Distance equals rate times time. Okay, and we're looking for distance this time. What do we know? We know how long it's going to take us. So we know our time. We know how far we're going. And so, let's draw that this way. And so we can just fill all of that in to find how far up the river the boat will arrive after 23 seconds, approximately 23 seconds. So 28.321 times 23.335, and so we get approximately 660.871, and that is distances in feet. So after 23 seconds, we will be approximately 661 feet up the river. Okay, so let's get to our dot product. All right, if we're given two vectors, v and w, we can find the dot product by taking the product of the x components, add it to the product of the y components. Okay, so let's try an example. It says if vector v is -2, 7 and vector w is 3, 4, we can find that dot product, and you write it as v dot w. We're going to multiply our x components and add to it the product of the y's. So 7 times 4. -2 times 3 is -6 plus 28. So v dot w is 22. So how can we use that with the vectors that we've been studying? So one use for the dot product is to be able to find the vector between the angle between the two vectors. So for example, when we had a triangle before that was not a right triangle, let me just draw any obtuse triangle. We could find this angle by using law of sines or law of cosines, depending on the information given to us. Well, now we will be able to find that angle using the dot product. So how would we do that? Take a look at what's in the box. It says we can find our dot product from the magnitude of V times the magnitude of W times cosine of theta, or more useful, let's solve for cosine of theta, divide both sides by the magnitude of V times W, and so we can come up with the angle measure using this formula. Let's try an example. It says, find the angle between V and W, given that V is -2.7 and W is 3.4. So the first thing we need to find is the magnitude of each. Okay, so let's grab a pen here. Let's find the magnitude of V. And remember, magnitude is just using our Pythagorean theorem. And so it's going to be -2 squared plus 7 squared, which gets us 4 plus 49. And 4 plus 49 is square root of 53. Okay, so my magnitude of V is the square root of 53. Let's find the magnitude of W. Same idea. So it's going to be 3 squared plus 4 squared to get 3 squared is 9, 4 squared is 16, 9 plus 16 is the square root of 25. Square root of 25 is 5. Okay, so we will use this information to help us find that angle between. So working with our formula, cosine of theta is going to be the dot product, V dot W, divided by the magnitude of V times the magnitude of W. Okay, and we already have all of our pieces, we just need to put it together. We found up above that V dot W, let's scoot my paper down right here, V dot W is 22 divided by 5 times the square root of 53. Okay, so we have, oh guys, this is bad math. Let me back up here for a second. And what I need to do is put that cosine of theta equals that. Okay, so how do I find theta? We're going to do cosine inverse of, and then this is just a calculator cruncher, 22 divided by 5 root 53. Putting that into our calculator, we're going to find that the angle is approximately 52.815 degrees. So let's just get a visual of what's going on here. So I graphed my two vectors. This is vector V, this is vector W, and our 52.815 degrees is that angle between those two vectors. So that's what we are able to do with the dot product. It's useful. All right, let's try another example. All right, it says calculate the dot product for each pair of vectors below and then find the angle between each vector. So we're going to do part B together, and then I want you guys to do parts A and C. Okay, part B, we have the vector -2i plus 4j. Well, what that really means is these are your unit vectors. So this is -2, 4, because this is -2, 0, and 0, 4. And technically these should be pointed. Okay, so, and then the same thing with 6i and -5j, or -5j, which would be the same as 6, -5. All right, so let's find the dot product, which is going to be -2, so it's the product of our, give me a second, I need to get rid of this. Okay. Our dot product is going to be -2 times 6 plus 4 times -5, which gets us -12 minus 20. -12 minus 20 is -32. All right, and then finding the angle between, we know that we need to do cosine of theta is equal to negative 32 divided by the magnitude of each vector. So we're going to do the square root of, we're not going to do it separately, I'm just going to put it all underneath this fraction bar. Negative 2 squared plus 4 squared, excuse me, times the magnitude of my other vector, which is going to be 6 squared plus negative 5 squared. Okay, let's crunch some numbers here. So we have negative 32 divided by, this is 4 plus 16, so this is the square root of 20, times the square root of, what, 36 and 25, which is 61. So we're going to do cosine inverse. Let's back up here. Theta is equal to cosine inverse of, guys, when you're putting this in your calculator, you need to use a lot of parentheses. And by a lot, I mean as soon as you hit cosine inverse, one set of parentheses is going to come up. Type in your 32 divided by, now you need another set of parentheses. Root 20 times root 61, end that parenthesis, and then end the first one that you started with. Hit enter. Please make sure that you can put this in your calculator and get the correct answer. So pause the video, crunch it in your calculator. All right, and so you should get 156.371 degrees. The dot product we found to be negative 32. Okay, so pause the video, and I would like you guys to do parts A and C. All right, welcome back. I know, some of you never even left. Anyway, the dot product for, let's move that. We're going to end up with 3 times 4 plus 2 times negative 2. Crunching that out, we get 8. And then calculating the angle, we're going to get cosine of theta is equal to 8 divided by the square root of 3 squared plus 2 squared times the square root of 4 squared plus negative 2 squared, to get an answer of, oops, let's screw this up here too, 60.255. I hope you were able to get that on your own. So let's move on to the next one. Part C is, actually we're going to discover something here. So hopefully you did the first part, the dot product, 2 root 3 times 5 root 3. Guys, when you're multiplying, this goes back to Algebra 1, when you're multiplying these, you're going to multiply your outside part, so 2 times 5 to get 10. Root 3 times root 3 is root 9, and then the square root of 9 is 3. So we're going to have 10 times 3, which is 30. And then negative 5 times 6, going up here, negative 5 times 6, we get negative 30. So 30 minus 30 is 0. So our dot product is, let's just throw that in our blanks here, 0. So let's find the angle between. Well, so when we go to find the angle, cosine of theta is equal to 0 over, now you just have to make sure that you're not dividing by 0. So that's why I put this in here, the square root of 2 root 3 squared plus negative 5 squared. Now that's going to be a positive number times another positive number, so I know I'm not going to get 0 on the bottom. So I'm going to have cosine of theta equals 0, and where does that happen? Well, that happens at 90 degrees, so my angle measure is 90 degrees. Okay. Number 49 asks, what does the results from part C tell us about the vectors? Well, if I have, let me scoot this up. Yep. If I have an angle of 90 degrees, that tells me that the two vectors are perpendicular. 90-degree angle. 90-degree angles implies vectors are perpendicular. Remember that symbol from geometry, the upside down T, perpendicular. Okay. Vectors that are perpendicular are called orthogonal, or orthogonal, depends on how you want to pronounce it. Tomato, tomato, right? And if that is true, if you have two vectors that are orthogonal, what must be true? Well, the dot product must equal 0. So two things are going to happen here. The dot product is going to equal 0. And the two vectors are perpendicular. In other words, we have a 90-degree angle. Okay, so let's take a look at the rest of our math notes. It says two vectors are orthogonal. In other words, they're perpendicular if their dot product is 0. A normal vector is a vector that is orthogonal to another vector. Okay, let's put this in our toolkit. So you can pause the video so you have time to write it down, but I'm just going to talk you through it. If you're given two vectors, you can find the dot product, also called the scalar product, by finding the product of the x's, add to it the product of the y's. Okay? Multiply your x's together, add to it the product of your y's. And then the second one is the angle between two vectors. So we can find the angle between two vectors, by taking the cosine, you're actually going to do cosine inverse, of the dot product divided by the magnitude. Okay, and I guess it would make more sense to box this part. Okay, so that gives you the angle between. Back when we worked with this in geometry, we would do the law of cosines, and this would be a triangle. Okay? And then finally, orthogonal. Orthogonal is just two vectors are perpendicular, and that occurs when the dot product is 0. All right, guys, that wraps up the last video of the online schooling. You do have a review that you'll have to do, but I'm not going to make videos for each of those problems. So check in with us and come to the Zooms if you have questions, please. Have a fabulous day.